everyone. This side Dr. Amit Kumar Pandey from ABES Engineering College. Today I am going to discuss deadlock. What is deadlock and introduction, necessary conditions for occurring a deadlock. So let's see one by one what is inside the lecture. What is deadlock? Deadlock is a situation in which two or more processes are unable to proceed because each is waiting for the other to release a resource. Deadlock leads to a halt in the system progress, resulting in unresponsiveness, applications, and potential system crashes. For example, suppose there are two processes A and B, and each holding one resource and waiting for the other resource. Process A is waiting for resource 2, which is held by process B1 and vice versa. We can check this here. Suppose here is a process A. A is demanding for resource type R2. Sorry. We will represent resource in a rectangle or a square and process by a circle. So A is waiting for resource R2, which is in possession of process B. This is already allocated to B. And B is requesting for resource R1. Which is already in possession of A. Okay. Here I mentioned dot inside the box of resource, which represent that there is only single instance of that particular resource, means single instance of R1 and single instance of R. So we can check here, A1 is requesting for R2 or already held R1, and B1 held R2 and requesting for R1, which is already in possession of A. So here this make a loop or cycle, and neither A nor B will get executed in this thing. Here is the jam. This is called deadlock. Now, conditions, those are responsible for occurring a deadlock. First is mutual exclusion. Means resource cannot be simultaneously shared. Mutual exclusion means resource cannot be simultaneously shared. Only one process can use a resource at a time. This situation may be lead to deadlock. Second condition is hold and wait. Means process hold resources while waiting for additional resources that are currently held by or used by another process. As we see previously in previous slide. So that was example for actually circular waiting. Next is no preemption. Means resource cannot be forcibly taken away from a process. They must be explicitly release the process holding them. If we cannot preempt the resources, then this also can lead to a deadlock. Finally, circular wait, which we discussed earlier in previous slide. There exists a circular chain of two or more processes. Each is waiting for a resource which is currently held by another process, next process in the chain on the loop. So here are the four conditions which must be satisfied for confirming a deadlock. So these are mutual exclusion, hold and wait, no preemption, and circular wait. Now, what is mutual exclusion? Each resource is either currently allocated to exactly one process or is available for allocation. Means either the resource is available for allocation or this is allotted to some process. Now, this says that if some process get a resource, then it will release it when it will get completely execute, and no other process can share that resource until that process will terminate. So this situation is not good for a system. This situation can lead to a deadlock. Hold and wait. Again, hold and wait is likely to circular wait. The difference is chain. In hold and wait, there is no cycle, no chain. Suppose there is a process A is requesting for R1, R1, which is currently in possession of B, and B is requesting for R2, which is in possession of C, and C is requesting for some other resource. And in this is hold and wait. Hold some resources and demanding for other resources, which are currently in possession of another process. This is hold and wait. No preemption, as we discussed earlier. Process hold allocated resources while waiting for additional resources. This was for previous one, hold and wait. No preemption means if some process gets some resources for its execution, and the resources will, if we do not preempt that resource or fetch that resource from that process for another process, then this is called no preemption. And a no preemption will lead to a deadlock. So there should be preemption for a smooth function. Now this is circular wait. There exists a circular chain of two or more processes, each waiting for a resource held by the next process in the chain. This is this is a hold and wait condition with a loop with cycle. If there exists a cycle with hold and wait, then this will be circular wait. Now, deadlock is a critical issue in operating system that occurs when processes are unable to proceed due to circular dependencies on resources. Understanding the necessary conditions for deadlock is essential for designing systems that can prevent, avoid, detect, and recover from deadlock situations. Effective deadlock management strategies are crucial for ensuring system reliability and performance. These are some references which I have used in my lecture. Thank you all. Thank you so much for being with me.